All right, welcome back, everyone. So all of that was just lead up to actually now talk about finding vulnerabilities. But like I mentioned a couple of times, I think it's really important to have that foundational knowledge and understand things like same origin policy. So now that when we start talking about what we're looking for, we can understand why things work the way they do. So now I'll talk about web application manual testing, or how we as testers or bad guy attackers actually look and find these vulnerabilities. Modern web apps can seem ridiculously complicated with all the latest and greatest JavaScript frameworks and tons of lines of code and all this communication happening. And they really just seem like magic, like when you're looking at web applications. But at the end of the day, it's really important to remember that every web application that we're talking about is just a client talking to a server over HTTP. Client is a browser, Firefox, Chrome, Safari. A server could be anything. I won't go into server lists or containers or VMs or wherever it is, but it's a server that's just sending HTTP back to our browser, and all the information that we see, interact with, do is encapsulated within that HTTP. So testing web applications is always just a matter of reading, sending, and modifying HTTP. Simplistic view here, our client on the left starts off and sends a GET request to a server. The server responds with a response. The response contains additional links or JavaScript that needs to be loaded. The client then sends more HTTP, and this HTTP dance just goes back and forth very quickly in the background, and all the stuff is actually loaded, but everything in the middle is just HTTP. So how do we see that HTTP, or how do we send custom HTTP? As I showed earlier, if we wanted to, if we really felt like we wanted to be elite hackers, we could just open up a command line and open a raw connection and type out HTTP by hand, and you can do that. But there's a much better way, which is to use what's called a proxy. And a proxy, or an intercepting proxy, sits in between the client, the browser, and the server, and snoops on or looks at all the traffic that's coming to and from. So in our simplistic example here, if we have a proxy, and this icon here is the logo for Burp Suite, which is the proxy we'll be using in the lab in the CTF. When we have that configured, our client on the left is talking to the proxy, but it thinks it's talking to the server. And the server is talking to the proxy, but the server thinks it's talking to the client. So we basically have set up a little like person in the middle type attack here, in which we are intercepting and seeing all the traffic that's going between the client and the server. So Burp Suite and OWASP Zap are two security-focused web proxies, but there's other kind of non-cybersecurity related web proxies that can also just be used for debugging or reading information. And proxies let us view, pause, and modify HTTP traffic in transit. Now, when we're testing web applications for vulnerabilities, the majority of the web application attacks that we're trying to find or exploit are really just based on sending unexpected HTTP requests to a server that doesn't handle them appropriately. So when we as software developers are building web applications, we are biased towards assuming the happy path. We think as we're building the web application that a client or a user is only going to use the application in the expected way. And so we oftentimes write our servers or our code to handle that happy path or that expected approach. However, when things start misbehaving or start sending requests that are bad or modified, that's where a lot of vulnerabilities lie, because servers and developers aren't equipped to handle those sort of edge cases. So the basic flow when we're doing web application testing or pen testing is we use the client and the browser to send good requests. We're browsing the site or the application normally as expected, and then we're using our proxy to inspect that and take a look at those quote unquote good requests. Then we're modifying them and making them quote unquote bad requests or unexpected requests and sending that to the server. A classic example would be if we're looking at a web application that's expecting an address form to be submitted, and we're sending our zip code. the normal expected request for a zip code would be something like 5 digits. And the web application may be programmed to only ever expect 5 digits. But by using a proxy here, we can take that request that's sending our zip code and start putting a bunch of garbage data in there or sending something totally random. So what would happen if I sent the server that's expecting a 5-digit zip code a 5,000-digit zip code? Or what if instead of sending a zip code, I sent a picture of a cat? Or what if I, instead of a picture of a cat, I just sent a malicious JavaScript payload? All these sort of edge cases that we may not be accounting for or thinking about are what we want to test. And if the server is misconfigured or vulnerable, the server may respond with what I call, this is not a technical term, a WTF response, which is really the server is just like, I was not expecting that. I'm sending something bad or sending something potentially wrong. And these WTF responses are what security testers live for, because this is where vulnerabilities can lie or be exploited. So some of you might be thinking, if you're already thinking about like, okay, person in the middle and snooping on traffic, like what about SSL or TLS? If I'm using HTTPS, like this should prevent all of this because traffic is encrypted end to end between the browser and the server. And if you're thinking that, awesome, kudos, because that's totally true. HTTPS is super important for this particular reason. If you are browsing a website like on a public Wi-Fi at a coffee shop and you're using HTTPS, someone should not be able to snoop or see or modify any of the traffic that you're sending. However, we are doing this to ourselves for the purposes of testing the web application. And since we're doing this to ourselves, we can actually loosen or disable some of the security mechanisms that TLS provides. So this works because when we set this up, we are explicitly disabling certain things like certificate checking to enable the decryption of TLS traffic so that we can see it. What this looks like is the browser, like Firefox, still thinks it's talking to the server, and it actually thinks it's talking over HTTPS. But it's talking HTTPS, it's talking encrypted to our proxy. And our proxy is decrypting the data and showing us the plain text. Then it's re-encrypting the data and sending it to the server, and the server thinks it's talking to the proxy. So it's encrypted between the browser and the proxy and the server. But in the proxy itself, where we're actually looking at things and changing things and modifying things, everything is plain text. And we'll configure this in the lab when we do Burp Suite, but tools like Burp Suite and Zap take care of this automatically for us. But we do have to disable some security protections on our own end. So keep that in mind. We can't do this to just anyone at a coffee shop if we're on the same Wi-Fi. We're doing this to ourselves because we want to snoop our own traffic so we can test things ourselves. So all that kind of leads me to my golden rule of web security. If you can take one thing away from this entire class and workshop here, it's my golden rule of security, which is never, ever, under any circumstance, not even for a second, not even a million years, ever even possibly consider trusting user input. If you write in your application, trusting the input you're receiving and expecting it to always be perfectly okay, you're going to have a really bad time. You have to write your applications and you have to write things in a way to handle the unexpected, to handle all the edge cases, to handle things and that you would never consider even happening, like someone sending you a cat picture instead of a zip code. You have to be able to verify or sanitize or err gracefully on anything that you're not expecting, because if you don't, that's where vulnerabilities can occur. All right, let's dive into the first vulnerability I want to discuss. Who's heard of cross-site scripting before? Cool, then this will be super fresh, new content. Cross-site scripting is like the scourge of the web. It is a classic vulnerability that's been around as basically, I think, as long as JavaScript and the browsers have been around. And it's a really nefarious way to bypass the same origin policy. And it can really have disastrous consequences if a cross-site scripting vulnerability is discovered and exploited on a popular site. First of all, cross-site scripting is a terrible name. I didn't name it. If I was in charge of naming this vulnerability, I would have named it something else, but it's called cross-site scripting, and that's just the de facto term for it now. But I think it actually causes a lot of confusion. But cross-site scripting occurs when an attacker is able to force a victim's browser to execute JavaScript within a trusted origin. But the cross-site part is, I think, what confuses people. It's not actually about loading or executing stuff cross-site. It's about loading and executing JavaScript within the same origin. So don't get confused thinking about cross-site scripting. A better word or a better term for this attack, I like to refer to it as content injection. We're injecting content into a site. We're not fetching content from cross-site, we're injecting it into the site. But cross-site scripting allows an attacker to completely bypass the same origin policy by getting malicious JavaScript to run within the same origin as the site that they wish to target. Yes, go ahead, Dan.
Yeah, how do they do the content injection? Like what kind of mechanism?
Yep, there's actually 3 different techniques that I'll talk about with cross-site scripting, and I'll explain them in the next couple slides here. But yeah, there's a couple different techniques that we need to be able to exploit here, or have the server be misconfigured to accept for us to be able to inject content. And any content can be injected, but when we're talking about cross-site scripting, the scripting piece there really means we're talking about JavaScript content. So JavaScript injection into a site is what we'll be talking about.
Awesome, thanks, Ronnie.
So remember that same origin policy disallows an attacker's script from interacting cross-origin. So our example here, my attacker website that I've tricked you into visiting, like my ropnop.com sketchy website, is loading sketchy JavaScript, but we're safe because the same origin policy says JavaScript that's loaded from my attacker origin cannot interact at all with something that's coming from Chase's origin. So my sketchy JavaScript on my sketchy website can't access Chase's cookies, Chase's storage, or modify Chase's DOM. But in a cross-site scripting attack, this malicious JavaScript is smuggled inside a legitimate HTTP response from chase.com. So the browser thinks that it's legitimate JavaScript and executes it within the origin. So visually, it kind of looks like this. I have my sketchy malicious JavaScript over here, but I'm able to inject it into chase.com. And the JavaScript is smuggled inside a response from chase.com so that when the browser loads it, the browser can't know that that was bad or malicious. It thinks that this is legitimate JavaScript that came from chase.com. And so it executes inside the origin boundary. And now all of a sudden it has access to the sensitive data that your browser has for chase.com, like your cookies or your browser storage or your DOM. Oops. So conceptually, it's a little bit like a Trojan horse type attack or something in which I'm hiding or smuggling malicious JavaScript content in a legitimate chase.com response to trick the browser into executing it. So these are the 3 techniques that we can use for JavaScript content injection. The first is called reflected cross-site scripting. In a reflected XSS attack, you're able to load JavaScript by reflecting it up to and back from the server. And this is usually done through targeting a particular user and sending them a link or a malicious attachment or something like that, that they will then click and open in their browser. Conceptually and visually, it kind of looks like this. If I send a link, say to www.chase.com/ and then a bunch of JavaScript in the URL, for example, and just imagine the red XSS letters here is bad JavaScript or malicious JavaScript code. When you click that link, your browser sends a request to chase.com, and it actually sends the payload up to chase.com. And chase.com has a vulnerability for reflected cross-site scripting. And what that means is that chase.com reflects or just echoes back to you what you sent it. So when the legitimate content comes from chase.com, my bad payload is reflected or echoed back to the browser. And because the browser then sees that this response came from chase.com, it loads it within the Chase origin and starts executing that JavaScript. It doesn't know that that was bad code that was just echoed back to me. All the browser sees is that, oh, this code was sent to me from chase.com, therefore it's trusted, and I will start executing it. And in practice, there's tons of places where this type of vulnerability could exist. You might be wondering, like, why would a server ever just echo something that I sent back, sent to it back to me? A canonical example here would be like when I send a Google search term for I want to search for like pancakes on Google, and so I send a search request to Google for pancakes. The search results page that comes back at the very top says, "Here's your search results for pancakes." That is a form of reflection because I have sent a request for pancakes and the word pancakes has come back to me in the response. So servers do this all the time. They will actually reflect or echo things back to you. And if they don't take proper precautions, if you can reflect malicious JavaScript back to the user, you could potentially have cross-site scripting vulnerability. The other main technique is called stored or persistent cross-site scripting. In a stored or persistent cross-site scripting attack, I, as an attacker, send a malicious payload to a server like www.chase.com, and somehow that gets stored in the server. It gets persisted in the server. Now, any user that visits this particular location that I've stored this payload in will retrieve my payload. And then that payload will again be interpreted as legitimate, trusted JavaScript and start executing. Conceptually, it kind of looks like this. Instead of me sending a link to a particular user and say, hey, click this, I will send a bad payload to a vulnerable server, and that vulnerable server will somehow save my payload, probably in a backend database. Then any user that then visits a particular page that fetches that payload will fetch the server will fetch the data from that database, return it to the user as part of a legitimate content response, and the browser will trust it and start executing it. I like to give a real world example here. One place where persistent payloads are a big problem are on social media or anything that accepts like a comment field. Right? If you were commenting on someone's post, you were sending an arbitrary comment saying like, oh, this is cool. And that string gets saved and persisted in the database. And then anyone that visits my post will read my comment. But if I'm able to inject something malicious into my comment and the server is not properly accounting for that, anyone who looks at that page could potentially be affected by loading this malicious content. There's a really cool story here in the early days of MySpace, actually, where a web security researcher, his name's Sami Kamkar, he blogs and has given talks about different security vulnerabilities. He found a persistent cross-site scripting vulnerability on MySpace, and he was able to put something on his MySpace profile that embedded malicious JavaScript. And then anybody who visited his MySpace profile, their browser would load this bad JavaScript from MySpace, and his malicious JavaScript, what it did was it would update their MySpace status to Sammy is my hero, and then it would embed the malicious JavaScript in their profile. So then anyone who visited that person's profile would then have their status updated to Sammy is my hero, and then their profile would be updated. So it started spreading like a worm, where it was initially his, and then anyone who visited his got infected, and then anyone who visited their profile got infected. I think within 24 hours, every single person on MySpace had their status set to Sammy is my hero, and he actually crashed and took down all of MySpace for like 48 hours because it just spread across every single MySpace user, and everyone suddenly was friends with Sami Kamkar, had their status set to Sammy is my hero, and he was the most popular person on MySpace within a couple hours. So you can look up the wiki article on Sammy is my hero or the MySpace cross-site scripting worm. This was kind of one of the first like big cross-site scripting attacks. It didn't really do anything malicious. He wasn't stealing information or anything like that, but it kind of demonstrated that a single persistent cross-site scripting, if coded in such a way that it spreads to other people's persisted payloads or persisted profiles, could really take down or affect every single user of a site like MySpace. And then the last technique is called DOM-based cross-site scripting. And this one's a little bit harder to explain or understand, but it's actually becoming a lot more common given the prevalence of single page applications or like React applications. So in a DOM-based cross-site scripting, they're able to load JavaScript by passing it into dynamic JavaScript that's already loaded and executing. So conceptually, what this means is, let's say I go to, and I'm picking on Chase up here. If I go to www.chase.com, and let's say Chase is using like React. And so Chase gives me app.js, and this is the Chase legitimate React application. My browser starts parsing that, executing the React application, and this is consistently running in the background, right? React is constantly running and updating itself. So that's a legitimate good application. If there's a vulnerability in that React application such that it reads malicious data from like a variable that gets passed in and starts executing it, we can actually inject bad JavaScript into JavaScript that's already running. So it could look like me sending a link to a user and saying, hey, click this link. And I put a bad JavaScript into a variable that's passed in via like a hash parameter on the URL. And the React application reads this variable, does something unsafe with it, starts executing it, and now I've hijacked or taken control of application code that's already running. The main difference between this and the previous ones is you can see we're not actually sending or talking to anything in the server. We're targeting the single page application or the running JavaScript that's already there. So if you're ever looking at vulnerability disclosures or bug bounty reports, or you see something like someone found a cross-site scripting attack, you may see something like this, which is alert 1. And alert is a JavaScript function that just pops up an alert box, and then 1 is the content of the alert box. So we might see something like www.chase.com says 1. It's a very quick visual way to demonstrate that you have JavaScript code execution, but it doesn't actually do anything malicious. It's very visual, it's easy to spot, but you might be thinking like, okay, so what? And I've actually had this discussion with engineers that I've shown cross-site scripting to, and they say, oh, you can open an alert box, like that's annoying, but so what? It's not about the alert box itself. It's about showing that I can call any JavaScript that I want, and calling alert 1 is just a very quick, easy way to see that JavaScript is actually executing. So if you are able to pop open, send a payload to somebody and pop open an alert box that says 1 or says hello world or foobar, it's a non-destructive way to prove that you have JavaScript code execution. But if a real attacker was doing this and we were trying to actually like weaponize it, we would never actually open an alert box. We would do something much more nefarious with our JavaScript code. So if you see alert 1, know that that's not actually like in itself bad. Like the alert box is not the big deal. The big deal here is that we are executing JavaScript from the origin www.chase.com. So let's say you have cross-site scripting. You found this vulnerability and you're able to exploit it. I mean, what can you do? I mean, the truth is whatever you want. Same origin policy no longer applies. So really that foundation of web security is off the table. Since JavaScript is king and controls everything within that origin, the attacker who controls the JavaScript code that is executing can do anything they want within that origin. So common attacks might be like, okay, let me read sensitive data or use your sensitive data like your cookies, or read your auth tokens or your access tokens from session or local storage. Since you can control the DOM, you could actually completely change what's presented to the user. You can change and deface or modify what the page is. One thing that you could do that's a common attack with cross-site scripting is to replace all the login fields with a different server that the responses get posted to. So you can present the user with like a login page that looks totally legitimate, but when they actually type in their username and password and hit send, they're sending it to you instead of sending it to the main bank. Any sort of AJAX request can happen in the background. You can really just execute anything you want within the confines of the browser and use any of the data or the resources that the browser has for that particular origin. I like to think of it as your browser is infected. If you are victim to a cross-site scripting attack, you have basically got a virus and you can't trust anything that you're doing on that origin anymore because the JavaScript that is executing on that origin is no longer trusted and can do anything that it pleases. So quick summary, cross-site scripting is really JavaScript content injection, and it bypasses the same origin policy because it's able to smuggle in content that comes from the origin, so therefore it executes within the origin boundary. And since JavaScript is so powerful and controls basically everything that we do within our browser on a page, if an attacker gets JavaScript control or JavaScript execution within that origin, all bets are off and they can pretty much do whatever they want. So it's full read-write access within an origin. So how do we mitigate this? Well, cross-site scripting is all about injecting content that the browser interprets. So going back to my golden rule of security, never ever insert untrusted data into the DOM directly. Never trust anything the user is sending you and then explicitly echo it back or store it without verifying it or checking it. So you can do that through things like input validation. This would be like, I'm expecting a zip code, but you're sending me JavaScript. I'm going to reject that request. Like a zip code should only be 5 digits, and I'm rejecting anything that doesn't match that. Sanitization is another technique. Because JavaScript requires special characters, you can remove the special characters or you can encode the special characters so that they don't work when they come back to you. And that's usually what occurs for most modern web applications is you can send things, but it will strip out or it will encode special characters like semicolons or curly brackets or open brackets, greater than, less than symbols. It will encode them. And when they're encoded, they lose their meaning to the browser. So they're not actually executed as valid code anymore. And you're safe from execution that way. And you can do this both on the server side and the client side. So within Django, output encoding is I think automatically enabled when you use HTML templates with Django. And Django has a built-in function called escape, which does exactly that, which is escaping things like open brackets, quotes, ampersands to their HTML encoding equivalents, because the browser won't actually execute HTML encoding. It'll just display it, but it knows that that's not valid code, so it doesn't try to execute anything that comes back from the server. On the client side, you should never write untrusted data into the DOM directly. JavaScript has an inner HTML function, which will let you inject raw HTML into the browser. That's ripe for abuse. However, JavaScript can use the inner text function, which will write text that's not interpreted as HTML or valid code that the browser will just display but never execute. There's also an awesome JavaScript library called DOM Purify that you can include in your client-side app and call anytime you need to display data that potentially came from an untrusted source like a user, which automatically purifies or takes care of all the special characters so that it will never execute and just display. And most client-side frameworks do this automatically for you. So the nice thing of using, React or Angular or a modern client-side framework is they use things like DOM Purify under the hood automatically to protect you from shooting yourself in the foot. If you're using data binding with a React component, like a functional component here, and passing in a prop like my data and then displaying it, React is smart enough and secure enough that will automatically sanitize and protect this. However, React does have a function which will disable that protection, and I believe it's called dangerously set inner HTML, which I love the fact that they named the function dangerously, because it just should be a red warning to you if you're ever writing React and you start writing the function dangerously set inner HTML. Think twice, or really think about what you're doing, because you're essentially disabling the built-in protections that React has. Any questions on cross-site scripting at a high level? And then when we get to the hands-on portion, you'll see some of this in action. All right. Then I'm going to move on to the next vulnerability we'll talk about before we break for lunch, which is cross-site request forgery, CSRF. So CSRF is, or it can be thought of as another bypass of the same origin policy. So we know, according to the same origin policy, that resources loaded from one origin should never be able to write data to another origin. If you load JavaScript from the attacker origin, that JavaScript shouldn't be able to initiate a bank transfer on chase.com or add something to your Amazon cart and hit buy now. However, there's two big notable exceptions to the same origin policy that same origin policy does not apply to. And it does not apply to HTML requests and cookies. The same origin policy was basically invented and implemented to stop JavaScript from doing bad things. But if you don't actually use JavaScript, then same origin policy doesn't apply. So CSRF is about crafting specific HTML payloads that avoid the use of JavaScript and rely on the use of cookies, so that same origin policy is never even invoked in the first place, and you can perform cross-origin writes. So let me explain that a little bit. JavaScript, right, does not, same origin policy blocks that. However, if I host a malicious web page on my origin and it's HTML, and inside that HTML is a form or a link or something that leads you to chase.com, the browser will actually make that HTTP request to chase.com, and it will automatically send cookies. If you recall when I said about cookies, browsers are very overly helpful in this regard. And if you have any cookies for chase.com, they get appended and added to any outgoing request from the browser to that origin. And because we did all this without JavaScript, the same origin policy is not enacted, it's not checked, and therefore this request is actually allowed to go through. And that request is called cross-site request forgery. So it's a little bit tricky, and it requires a few things to actually be true in order for it to work. The first is that it requires a state-changing request. So what that means is CSRF is really a write-only operation. Sorry, was that a question? Okay, so CSRF is really like a write-only operation. It's like a blind perform an action, but you can't actually read any data with it. So it requires usually a post request that takes action, meaning like initiate a transfer or buy something or update something. It can't be a request to just read something. CSRF also requires cookies. It abuses the way that browsers handle cookies. So if your application is using a access token like a JOT instead of a cookie, there's no CSRF. It has to use cookies. And it requires user interaction. So a victim must visit a site or click a link in order to initiate this. But it abuses the stateless nature of HTTP, the way browsers send cookies, and the fact that when there's no JavaScript invoked, same origin policy does not apply. So visually, it sort of looks like this. Let's say that I discover as an attacker a particular vulnerability in action on chase.com, like initiate a money transfer. And that is a post request, and there's a particular request that a user who's logged in to chase.com can send to initiate this fictitious money transfer. I craft a special CSRF payload and I host it on www.attacker.com. And then I send a link to an unsuspecting victim and say, hey, click this link. This victim or this user is already logged in to chase.com and they already have valid cookies for chase.com. Their browser loads my attacker.com site, and my attacker CSRF HTML comes back and gets executed within, or gets rendered within the browser. And that HTML includes a form that posts to the account money transfer endpoint. And because they're already logged in and have cookies, the browser automatically sends the cookies to the server. and the action is successful and takes place. And in this CSRF payload, I can then, take some fictitious action like send myself money or perform some sort of other action on chase.com that abuses and uses their cookies. And CSRF payloads are very simple. They're just HTML. There's no JavaScript really, because if you start sending requests with JavaScript, then same origin policy kicks in. So this would be like a CSRF example. I would host this on my attacker website, and you would load it. And there's a HTML form that sends a post request to chase.com/account/transfer with a couple hidden values like who it's sending to and the amount. This is obviously all made up, of course. And then there's just a little bit of JavaScript that finds the form and submits it as soon as the page is loaded. So what happens is when your browser parses this HTML, this form is automatically submitted and these values are automatically sent to chase.com. And the browser then looks in the cookie jar and says, oh, you already have a cookie for chase.com, I'll include that. And the server doesn't know that that was a unintended or unwanted request because the server gets the valid cookies and says, oh, okay, yep, you want to initiate a transfer, no problem, I'll do it for you. This is a screenshot showing what happens. I actually executed that payload against myself, or I clicked the HTML link, and my browser immediately sent off a post request to chase.com/account/transfer. On the bottom, we can see the values that I had hard coded in my CSRF payload, which was just 2 ROPNOP and the amount of 1,000. But all of this in the top red box, these are cookies, and these are cookies that were automatically sent. I did not consent to send those cookies. I did not tell my browser to send those cookies. The browser just automatically sends those cookies because it had those cookies and they matched the chase.com domain. So all of these, I mean, some of these are tracking cookies. I don't even know what any of these cookies do, but this is just to show you that the browser automatically sends these when it finds a matching outbound request to a domain that it recognizes in its cookie jar. And if one of these cookies is all it takes to actually verify or authenticate myself, then the browser will treat this as a legitimate request and execute the action. So CSRF prevention must happen on the server side. And the traditional defense is through what are called Synchronizer tokens or CSRF tokens. What this is basically a random value that gets appended to each form before an action is going to be taken place. And when the form is submitted, the server has to verify that that random value matches the initial value that was sent to the user. So it does require remembering state because you have to remember the random values you send to your users. But thankfully, frameworks help a lot here. And Django or Rails take care of this automatically, and this is built in. So whenever you have a form or something that's being handled by Django or Rails, they will automatically include some sort of synchronizer token to try to prevent this type of attack. But another option is to use the same origin policy. This would never be allowed if the same origin policy was invoked, but the same origin policy only applies to JavaScript. So another way we can prevent this is just use some JavaScript. JavaScript is actually more secure in this fashion than not using JavaScript at all. And we can do that by 2 different approaches. And I won't go too deep into these, but just for your awareness, double submit cookies or custom headers. The idea here is that we have to use a little bit of JavaScript, and we'll have JavaScript send the request, not HTML. And JavaScript will send the request by either appending a custom header or adding a custom value to the body that it reads from a cookie. It looks like this. We basically have the same form that we want the user to actually submit, but we have a little bit of JavaScript that hijacks the form submit. So JavaScript is the one that's actually sending the form and not HTML. And JavaScript is reading a value from a cookie, adding it to the form body, and then sending it on. And on the server side, it looks like this. When the server receives a request like this, it has a cookie, but it has another header, or another cookie value, I should say, called a CSRF token. And the CSRF token is also inside the body here. And the server just has to verify that these two values exist. And if they do, the request had to have come from the same origin because JavaScript was able to do this, and therefore it should be allowed. If these don't match or they don't exist, then you can reject it. And that's what most modern frameworks will do. And client-side frameworks will do this automatically. I don't know off the top of my head how React does it, but Angular will actually always send a Xsurf token cookie in its requests on any form that Angular is sending, specifically to prevent this type of attack. Likewise, another approach would be to use JavaScript to send a custom header. The only way you can send custom headers from a browser is using JavaScript. So if you have a custom header called Xsurf token, or whatever it could be called, anything, the server only needs to validate that that header is there, because it can assume that if the header is there, JavaScript sent it. And if JavaScript sent it, the browser wouldn't have allowed that because of same origin policy. So in quick summary, CSRF is a very convoluted or complicated issue that's been around since as long as cookies have been around. But it basically abuses legacy behavior to not invoke the same origin policy. So it's not so much a bypass of the same origin policy as it is just finding a way so that same origin policy just never applies in the first place. It allows an attacker to write data cross origin, but it can never be used to actually read data. So CSRF is all about take some sort of blind action and hope it succeeds, because you can't actually, as the attacker, read or look at any of the response that comes from there. And it can and is easily prevented via same origin policy, as long as we make sure that same origin policy applies. I mentioned earlier, the OWASP top 10, which are like the top 10 most common or most critical vulnerabilities. CSRF was on that list for many, many years. And then last list that came out like 4 years ago, it finally dropped off the top 10. So CSRF, I'd like to think you kind of think of as hopefully a dying vulnerability. The reason that CSRF is so less common and prevalent than it once was is because JavaScript has risen to be much more popular, and CSRF doesn't apply to JavaScript single page applications. And modern frameworks like Angular, React, Django, Ruby on Rails prevent this out of the box, and so you have to explicitly disable it. Before we had all these modern frameworks that did this securely, if you're writing something from scratch, like in PHP, this was all over the place. All right, I really flew through CSRF there. So I will pause. Did any of that make sense, or your eyes just all glazed over? So I fully admit that CSRF is one of the more crazy, weird vulnerabilities.
I think we're all using the headers in our personal projects and other projects. So, but it helps to understand what's actually going on now.
Awesome. Yeah. So it's like I said, it's thankfully one of these vulnerabilities now that should just be like an afterthought. You don't really, if you're just using the framework out of the box as it's configured, you should be protected from this. And that's why we see the prevalence of this vulnerability has gone down drastically in most modern web applications. It still exists, however, anytime you either do something custom or disable the protection, or unfortunately, I've seen cases where someone was writing a Ruby on Rails app and they kept having weird errors, and so they Google Stack Overflow, and the first response is oh, just add this annotation to your controller, it disables CSRF protection. And they do it because it fixes their problem, but they don't understand that just opened up their controller to CSRF vulnerability.
And that's actually what we did before we learned about how to actually use the headers correctly. So yeah.
Yep. Yeah, it makes sense when you're developing rapidly or just need to whip something up, and just be be cognizant or aware when you're disabling protections like that, what you're actually doing. And then when you get it working, go back and re-enable it if you have to.
I have a clarifying sort of thing. Like, so when we were learning Django in class, like we used these HTML like templates or something, and then we use forms, right?
Yep.
And then it would like it would like execute some sort of Python function. But then now that we're using React, like we have to use these, like on the front end, we have these, I guess we get the input, but then we use like an axial request to send it to the back end. Is that so the second way more secure than the previous way where we had forms and stuff?
Yeah. I won't say more secure, because you can certainly make forms secure. Like if you're doing the proper Django CSRF protection, like that's perfectly secure in a perfectly valid way. So I wouldn't say if you're just using Django, rewrite it and use React. But when you are using React, and if you're using something like fetch or Axios to make a request, that's JavaScript sending that request. So same origin policy kicks in. So you get the added protection or the added benefit of same origin policy applying to those outbound requests. And there's certain things that same origin policy won't allow. And I think, in React, you're probably doing something like one of these two things, which is a double submit, which is like what Angular does, which is a custom cookie and a custom value that has to exist there, or a custom header that React or Axios is putting there. And then on your Django server, all you have to do is validate that that header exists or that the values match within the cookie and the body. And then you'll know that this is a legitimate CSRF or legitimate request and not a CSRF request. One other clarifying point, though, that I just dawned on me as I was talking: when you are sending a request from React to your Django app, is it a form body like what we see here, or is it JSON body?
I think I'm pretty sure it's JSON body that we send.
Okay. Yeah, that wouldn't surprise me. Like most APIs for like a single page application are talking JSON to a server, and the server's responding with JSON. So it's not HTML forms going over the wire, it's just JSON body. That's an additional protection. CSRF does not, I'm choosing my words carefully because there's like edge cases here, but basically for the most part, CSRF is not possible with JSON bodies. Like CSRF has to only occur with HTML bodies and HTML forms. So if you're just sending JSON bodies, CSRF is essentially eliminated. Cool, good questions. All right, the last class of vulnerability that I will talk about is injection attacks. Going back to the OWASP top 10, the #1 vulnerability for web applications every year since OWASP released its first top 10 has been injection. Injection attacks are devastating attacks that take many different forms, can be hard to detect, but when they're exploited, can be very bad. There's a key difference between injection attacks and the cross-site scripting and cross-site request forgery attacks that I just mentioned. In a cross-site scripting or a cross-site request forgery attack, an attacker is targeting a user. They're trying to abuse or compromise a user or a user's session on the server. So I'm trying to compromise, you and your Chase account, or I'm trying to compromise or send a payload that abuses functionality and get you to perform an action like send me money. So I'm targeting the user of Chase. Injection attacks are server-side vulnerabilities. So I'm actually targeting and trying to exploit the server and the company that's hosting the server. So there's a slight difference there when we talk about injection attacks, and this is the reason they're considered like worse or have higher impact, because they are targeting the server, the company itself, and not the users of that company. And it abuses the server's handling of unexpected or untrusted input. So you definitely, remember the Ronnie's golden rule of web security. An injection is also a bit of a catch-all vulnerability, but it can take many forms. So the most common form, and the one I'll talk about of injection, is SQL or SQL injection. But other types of injection vulnerabilities exist, like command injection, server-side template injection, server-side request forgery is a form of an injection. Injection is really just about sending bad, untrusted input to the server, and the server's processing it incorrectly on the server side, not necessarily sending bad data back to a user's browser. So the web is, like I said, almost all HTTP. It's browsers and servers talking HTTP. But the truth is, modern web applications have multiple other technologies. Usually you have, your web server that's written in Python using the Django framework, and then you're going to have to store and retrieve data. And then to do that, you're going to use a database, and you may be using MySQL or Postgres, or you might be using something like Mongo. Other servers might have Redis or queuing systems or different cloud technologies. Like, there's a lot of different technologies in play in modern web applications. And so servers have to perform this sort of like translation. They have to be able to take a request from a user that is always and only sent over HTTP, but then on the back end perform some sort of action using a totally different technology. And in this case, for example, if we're talking to a database, that language or that technology might be SQL or SQL. So let's say in our hypothetical example here, like for logging in or looking up a particular user with a web application, we're sending data to the server over HTTP. And that could look like an HTTP form, and it could just say username equals Ropnop. But the server needs to fetch data from the database about the user Ropnop. So the user or the server turns around and has to talk a totally different language, a different protocol to a MySQL database, and it talks SQL. And that SQL query could look something like select star from users where username equals Ropnop. Are people familiar? Have you seen SQL or SQL before?
Yes, we have.
Cool. So yeah, this is really common use case for web applications that have a database, but you can kind of think of the server as performing a little bit of like a translation act here, right? It's reading HTTP, it's reading a value, and then it's constructing SQL to actually fetch the data it needs from the server. So then the database sends back information about this username, but the database is sending back to the server raw SQL statements. So all the data that's in the column, the databases. The server then has to turn around, translate that again, and send it over HTTP back to the client. So this translation layer between like HTTP and SQL, or HTTP and Redis, or HTTP and Mongo, whatever the backend technology is where injection can take place. So SQL injection is what happens if untrusted user input is used to construct other commands. Then really bad things can happen. We are, talking SQL to the server, and we are deciding what SQL to send to the server based on what the user is sending us. This is a recipe for bad things, because if we're not trusting that, or if we are trusting that and we're not validating it, the user could actually send legitimate SQL over HTTP and trick the server into executing that. Classic example of SQL injection is, let's say I send the server that my username is Ropnop single quote space or space 1 = 1 semicolon dash dash. I joke and say, oh, that's my username. The server, if it's not handling the stuff correctly, would take that username and plop it right into the SQL statement. if you remember the previous slide, it's taking ROPNOP and it's just putting it here at the end of this statement. Well, now it's taken this whole string and put it at the end of the statement. So now we have select star from users where username equals ROPNOP. And then here I have my single quote, space or space 1 = 1 semicolon dash dash. Who can tell me what this SQL statement is going to do now?
I think it's going to give you everything from the database.
Yep, you are correct. So what I've basically been able to inject here into the SQL that gets parsed is this space or 1 = 1. When we're constructing SQL, we're fetching everything from the users table where, right, this where clause has to be true. It should just be where the username is ROPNOP. But when we have or 1 = 1, well, 1 = 1 is always true. And if you ever have a where statement that is ORed with something that's always true, then it becomes always true itself. So this is essentially saying select star from users, period. Like give me everything from the users table. We also were able to add in a semicolon and a dash dash. In MySQL, dash dash is the start of a comment. So we're actually able to comment out the remainder of the query by putting a dash dash in there and ending it with a semicolon. So when we inject this, we've now tricked the server into executing SQL to dump the entire contents of the users table and return that to us instead of just fetching the data for our particular user. So SQL injection is an attack that lets you escape a normal SQL query and inject arbitrary raw SQL parameters. And it gets really complex really fast when you start doing this. That's a very simplistic example, but a real SQL injection attack will start looking like ridiculously complex, cool SQL statements that get put together. And it could be things like using more advanced SQL stuff like unions and joins and cat to perform things. There's a great tool called Sql Map that is a tool that when you identify a SQL injection vulnerability can be used to automatically exploit it by identifying like the particular dialect of the SQL server and then sending custom SQL queries to pull data out. And you can see some examples here of like, you know, how it starts simple where the first payload is ID = 1 and 6489 = 6489, which is that or true. But then it can get even, you know, much more complex where like ID = 1 and select 7857 from select count can cat some hex value with select a random value from the plugin group by, or down here, right, select null can cat with more hex values. This tool is basically constructing very complex SQL queries to pull information out of the database and return it to you. There's really cool techniques that you can see. For example, blind SQL injection occurs when the server won't actually send you the responses, but you can still infer information from how the server is reacting. So there's a technique that you can perform manually or with something like Sql Map, where you can issue a sleep command in SQL, which will basically just pause for like however many seconds. So you could start writing SQL queries that say, if the first letter of the first row of the first table is A, sleep for 3 seconds, otherwise sleep for 1 second. And then you actually time how long the response comes back. And if it takes 3 seconds, then you now know that the first letter of the first row of the first table is A, and you can go from there. But if it's come back in 1 second, it wasn't A. So then you send a follow-up and say, okay, if it's B, sleep for 3 seconds. If it's C, sleep for 3 seconds. And you can literally pick out data 1 character at a time by checking the response time and sending things like that. So how do we mitigate SQL injection? Again, I'm going to beat a dead horse here. Never, ever trust user input. Anything that the user is sending you you have to treat like it's nuclear waste and not ever actually just parse directly or inject directly into like a SQL statement. So popular methods here are to escape everything. Well, first of all, you can reject things. So in our zip code example, if you're only expecting 5 digits, reject anything that doesn't match that, right? Why would you accept a zip code that has like proper SQL statements inside of it? But if you don't have that option of just rejecting everything, you can escape things. Just like with our other example of cross-site scripting, if certain special characters are encoded or stripped, then they won't actually be executed. So escaping things means like strip out quotes, strip out anything that's valid SQL, like stars or %signs or anything that might be construed as valid SQL. Escape it or remove it before you actually parse it. Another option is things like stored procedures within SQL databases. Depending on the database you have, you can define custom functions that will operate on parameters that you can call without having to actually construct raw SQL yourself. Or the best example, if you're using a framework like Django or Rails, is to use an ORM. And Django has its own ORM, which and so does Rails, which basically like let you not have to write SQL. You can write it in Python or you can write it in Ruby, and under the hood, they're doing this type of stuff securely. So up here, this is the example of what you should not do. If you are writing Python and you are writing a SQL statement using like a string format, select star from users where username equals, and then plopping a string in there with the username string, and then calling db.execute, db.fetch_all, that's SQL, that's a recipe for SQL injection. Instead, if you're using Django and you have a user object, just do user.objects.filter name equals username. And Django does this securely under the hood, and you won't have SQL injection if you do it that way. So if you ever find yourself writing raw SQL, really reconsider that. Look for the framework. Reach first for like the paved road here that Django provides or Rails provides to prevent you from having to do this yourself. All right, cool. And we're just afternoon. So what I'd like to do is just leave you with these instructions, and then we'll take like an hour-long lunch break. But we'll come back and we'll do a hands-on lab together and then kick off the CTF. So I've got a vulnerable web application that we'll all walk through hacking together just to see how some of the attacks work and use and get familiar with a tool, Burp Suite, and then we'll do the CTF afterwards. So if during your lunch break, if you can, I would ask you all to download and install Burp Suite Community Edition. Burp Suite is from a company called Portswigger, so the URL is portswigger.net. And you can find the community edition, which is their free version, which is more than enough for what we're going to need to do for the lab. And they should have the installs for all the different operating systems. It's not a huge download, but if you're on a slow internet connection, get that started. And then if you can install it, when we come back from lunch, I'll share my screen. We'll walk through Burp Suite's functionality together, and then we'll test our deliberately vulnerable application. Any questions before lunch? I didn't even pause for questions about SQL injection.
Yeah, Ronnie, I actually have a question.
Sure.
Just curious. I know for like our development, we've been using Chrome because it has like a really good set of dev tools. Is there any kind of equivalent, like your line of work, of like a preferred browser that gives you something that the other ones don't?
No, I mean, I actually use Chrome myself. I used to use Firefox for all my testing, but that was mostly just because I use Chrome for my personal stuff, and I just used Firefox for testing. So having like, 2 separate browsers just let me have like different extensions installed in Firefox for testing, and Chrome was what I used for my day-to-day. Burp Suite, as we'll see when we walk through it, actually includes its own embedded Chrome browser to do the testing with. So we'll be using a Chromium browser that's built into Burp Suite to do it. So I'd say Chrome or Chromium are probably, just because they're the most popular browsers in the world, what most people use. Firefox is also really popular though for keeping it separate, like me, which is like I use Chrome for personal use, Firefox for testing. But any of the main ones are fine to test with. You just have to make sure you're configuring them to work with your proxy.
Excellent, thank you.
Yeah, good question. All right, everyone. Thanks for listening to me chat, listening to me talk all morning. But let's take a lunch break and install Burp Suite, and then we'll come back at a little bit after 1 and jump right into the hands-on stuff.
Thanks, Ronnie.
Cool. All right, cool. Welcome back, everyone. Hope you had a good lunch. So from now until the end of class, we'll be doing more hands-on stuff with Burp Suite Community Edition. So if you haven't already, please try to download and get it installed. And if you want to open it up, that's fine. We're just going to do a Burp Suite walkthrough. So Burp Suite is an intercepting proxy that's made for security testers. It's got a million bells and whistles, tons of functionality. The truth is, I only use like 5% of what Burp Suite even has available to it. I mean, it's got a tool for like everything and lots of extensions to add on, but today we're gonna just focus on a few like core things that we can use Burp for. So I'll walk through a couple slides just showing Burp Suite, and then I'll get out of the slides, and then I will open up Burp Suite on my laptop and we'll do a walkthrough. And then we will all together hit a target vulnerable web app and then walk through some of the solutions or showing the exploits together, Q&A, and then the last hour and a half of today, we'll do the CTF, or we'll set that up. Okay, so when you open up Burp Suite Community Edition, it'll ask you to set up like a new project, or there's some defaults. You can just click through and accept them. But this is what the main kind of page of Burp Suite looks like. And there's 10 different tabs on top, or a dozen different tabs on top with different functionality. The main functionality that we're going to be using is the proxy functionality. And so this is what I was talking about before break, is we can configure a browser to talk to the proxy and the proxy to talk to the server, and it'll let us see, intercept, and modify all the traffic that goes through them. So if we hit the if you hit the proxy tab and the intercept tab, and you can either follow along or I'll open Burp Suite in a minute and we can do this together. Burp Suite has a really cool feature. This wasn't always the case. And actually, when I first started doing this class, there was like more steps because we had to download another browser and configure that. But now Burp Suite actually has a built-in embedded browser that is pre-configured to already proxy to Burp. So if you hit the open browser button on the proxy tab and then the intercept tab, it will open a pre-configured Chromium-based browser that will be already be configured to send all of its traffic to Burp. So it's awesome. We can use that. You can use any browser you want, but you'd have to manually configure that browser to use Burp as a proxy. And I won't go through that because we don't need to for this, but we'll use Burp's embedded browser. By default, when Burp Suite fires up, the proxy is set to intercept everything by default. And we can see that in the proxy intercept tab, this button here, and apologies, I don't know if you can see my mouse cursor, but there's a button that says intercept is on. When intercept is on in a proxy like Burp, it actually doesn't send any traffic. It pauses and halts every single request that the browser is trying to make because it's prompting you for an action. And that action can either be forward it, drop it, or modify it. So if you open up the embedded browser and try to browse to google.com or something else, it'll actually look like your browser is just hung and it's loading forever. It's not actually like frozen, what's happening is Burp is just pausing the outgoing request and asking you what you want to do with it. So for each request, you can either forward it, which means go ahead and send it onto the server and the browser will get the response. You can drop it and not send it, or you can actually click in and modify it. And I'll walk through, we can do that all together in a little bit. But the main thing is that can get really annoying if you're browsing a website and every single request you have to approve and say like, okay, send that one, send that one, send that one. So I rarely actually have Intercept on. And you can toggle that by clicking the Intercept is on button. When the Intercept is off, all traffic is just passed through Burp. It doesn't actually stop or prevent anything from happening, but it is logging everything. And that's what we really want at first, is we just want everything to be logged so we can go back in time and see everything that happened. Oops, skip that. So I think it's actually easier for me now at this point. Instead of showing you screenshots, I will just open up Burp Suite, or we can all open it up together and we'll go from there. So give me 1 second. I will share my desktop. Okay, hopefully you can see at least part of my screen here. So I'm on a Mac, but Burp Suite's cross-platform, so Windows and Linux will look a little bit different, but well, it'll actually look mostly the same, but all the steps should be the same. So when we fire up Burp Suite Community Edition, it'll prompt us to basically just create a temporary project. This is the main limitation of the Community Edition, is you cannot save the project. So once you close Burp Suite, you will lose all your history. Burp Suite Professional, which I think is like $400 a year, allows you to save projects. It also has some more like advanced features. We really don't need those. I pay for it, or my work pays for it, I should say. But the Burp Suite Community Edition is actually super powerful just by itself. So we're just going to click through temporary project, and we'll use the Burp default configurations and hit start Burp. And if anyone is following along and has problems or issues, please speak up. We can do troubleshooting together. You can share your screen or we can walk through it all. All right, so like I said, a lot going on here. It's a very busy screen. But the main tab that we're going to be spending the majority of our time in is the Proxy tab up here. So all of these tabs are different features of Burp, but we want to use the Proxy feature. And if we hit the Proxy, then there's 4 sub-tabs: Intercept, History, WebSockets, and Options. Under the Intercept tab is where we should find the button to open the browser. So when we hit Open Browser, it will load up a Chromium-based browser, which will look very similar to Chrome and land you on a Burp Suite page. This browser is already pre-configured to talk to Burp Suite and to proxy all its traffic through here. So anything that we browse in this browser will appear to us in Burp Suite, and we can modify and view that traffic. So I see some people in chat. The Intercept toggle is right here, where mine is blue right now. It says Intercept is on, and you can see it actually just caught an outgoing request and it's frozen it right now. We can toggle that by just clicking it. So if it's not blue and Intercept is off, then we're not actually pausing or halting anything. I'll show you just what it looks like if Intercept is on and I try to go to google.com. I can see my browser looks like it's just hung. It looks like it's just loading, but it's actually waiting in Burp Suite for me to approve or deny an outgoing request. And you can also tell because the tab will light up orange. So if you see your Intercept or your Proxy tab highlighted orange, it means that a request is waiting for your action. So I'm going to toggle Intercept off. And we should see the main google.com page load here. And then I'm just for demonstration purposes, let's just search for foobar, and I'll hit enter, and I'll see like results come back for foobar. So everyone following along so far? So if we have Intercept off, you can see I'm able to browse in my Burp browser as I normally would on the internet. Oh, so what is Chromium? So Chromium is essentially the open source version of Chrome. So the code base that makes up Google Chrome is called Chromium, and Google Chrome is the open source code base with a lot of like Google's additions on top of it. But Chromium, the project, and the JavaScript engine and the whole browser code base is actually open source. So Burp Suite embeds the open source Chromium, essentially the open source version of Chrome as a browser. And you can actually download and install Chromium if you want like a Chrome browser that's not actually like a Google Chrome browser, and it works much the same.
That's why the new Microsoft Edge browser is actually pretty good, because it's actually Chromium based too.
Yep. Yeah, good call. Yep. So Chromium is the browser engine. It's like there used to be Internet Explorer, which was its own browser engine, and then you've got Firefox, which is the Mozilla browser, Safari or WebKit, which is the Apple one, and then Chrome, which was Google. But Chromium became so powerful and such a standard that now like Microsoft ditched it, and Edge is also based on Chromium, but it's the Microsoft flavor of Chromium. Firefox is still separate, and Safari is still separate. Cool. Dalton, when you search, if it's just loading, make sure when you look at Burp Suite, if any of these are orange, you may have Intercept on, and you might want to just turn Intercept off. Yep. Okay, so we've been browsing and we have Intercept off, so it doesn't look like Burp is doing anything. But if we go to the HTTP history tab under proxy, so right next to Intercept is HTTP history, what Burp is doing is actually logging every single request that our browser is making and the response that's coming back from the server. So all of these are actually in sequential order. You can filter or you can sort them based on order. I think I have my default sort is the newest ones are on top, but you can sort the oldest ones on top, but I like keeping it with the newest ones on top. And every single one of these requests is what my browser is making. And you'll see your browser is very chatty, especially just going to a site like Google and doing a single search. My browser made 111 different requests to servers. If we click on one of these, I'll just pick like a random one. Down here, Burp will actually show us what the raw request looks like. And then on the right, it'll show us what the raw response looked like. And again, this is messy. There's a lot of data here, but we can kind of like take a look and see, this is HTTP. This is just raw HTTP. So it starts with a post. It's the verb. So this is a post request to this particular URL. Then there's headers like host. My browser sent all these cookies. I've got a ton of other headers here. Then there was no body. And then the response came back from the server. It was a 204, no content. So that wasn't a great one to look at. But if we look at something like, I mean, I don't even know how to begin to decipher this. This is something, but Google sent a request for some sort of JavaScript, and then the response came back, and there's a bunch of JavaScript here on the right that was sent to my browser and is being executed. But the main thing that, to take away from this is you can go back in time and you can click on any request and you can see the request and the response that was sent. And so this is a way to kind of like decipher or reverse engineer a little bit when we're looking at a web app of like what's actually happening. So one thing that I'd like to look for if I'm just doing a web test is like, I know I looked for the phrase foobar, right? I did a Google search for the phrase foobar, but what did that actual request look like? So I kind of have to like scroll through a little bit and find the actual request. But right here, my request 67 was a GET request to /search with a variable q, which is foobar. So this was the actual request talking to Google to actually give me the search results for the phrase foobar. And actually we can, if we look back, we can see that as I was typing, you know, there was type ahead completion. Every single character I typed, it was sending a request to get /complete/search for FO, FOO, FOOB, FOOBA, et cetera, et cetera. So this is the history tab. It's your best friend when you're doing web testing. As you're using a site normally, you can then backtrack, look at the history, find things. I will show a few other tabs that are useful within Burp Suite before we get to our main site that we want to be testing. The target tab, what's nice in the target tab within Burp Suite is under sitemap. It'll take basically everything that's in your HTTP history and organize it hierarchically by domain. So we can see and expand these out, right? We have HTTPS google.com, or here's www.google.com. If we expand it out, then we can see all the subdirectories that it's requested there, and then click into one of those and then see the actual requests. So it's another way to kind of like organize or map out sites as you visit them within Burp Suite and see all the requests that are going and coming. Another super useful tab, actually I use this all the time, even if I'm not doing web stuff, is the Decoder tab. If you recall how we can, in the web, right, certain bits of data can be encoded or decoded in a lot of different ways. The Decoder tab lets you do all of this in a bunch of different ways. So if we need to encode something as we're testing, say we need to encode the phrase like hello world, you can actually type in this top bar, and then over here, you can hit encode as, and we can switch that to base 64, or we can encode it as octal, or that's a bad one because that's the same, ASCII hex. Then likewise, if we have something here, we can hit decode and then decode it back to plain text. So the Decoder tab is super useful when you find something that you think might be encoded, you want to try decoding it. And I will show actually what we can do is, if we are looking in our history here and we see something that we think might be base 64 encoded, like this looks, what I'm highlighting right now, this looks like it might be base 64 encoding. We can actually highlight what we want, right click and hit send to decoder, and it'll automatically put that text for us in this decoder box. And then we can try to decode it as base 64. In this case, decoding it as base 64 returns a bunch of gibberish. So this isn't actually decipherable, or could be a couple of things. Could be encrypted data, could just be random data. Essentially, it's not a string that's just decoded, that's just encoded to base 64. But right-clicking text and sending it to decoder, excuse me, is a useful trick. I think the last function that I will show that's also very useful is if we find a particular request that we really want to like focus in on and test over and over again, is the repeater tab. So if we find let's find that request for my particular search. It was this request right here was sending a search request for foobar. If we click on one of these requests and right click anywhere inside here and hit send to repeater, this repeater tab lights up orange. And if we go to the repeater tab now, we're in this new view where there's a raw request on the left-hand side and a send button. And if we hit the send button, Burp will actually just repeat and send exactly what's on the left-hand side and show us the response it gets on the right-hand side. So I resend this and I can see that the server gave me a 200 OK, same headers, a bunch of HTML and JavaScript. Down here in the bottom corner, it tells me that this was 602,000 bytes and it took 680 milliseconds. What's useful about the repeater tab, though, is not just repeating and sending things, is that I can actually change anything I want on the left-hand side and then hit send again. So if I say, for example, wanted to know what would happen if I didn't send any cookies, I can highlight and just delete all the cookies and say, okay, what happens if I don't send actually like any of these headers? Will anything break? And then I'll hit send again. And it looked like I got a 200 okay. And then I can compare it with 600,000 bytes. So it actually gave me a good response without any cookies or without any other headers. And I can just start deleting things and seeing what happens. So I deleted too much there. I got rid of too much stuff because it didn't have the right headers anymore. And now Google gave me a 400 bad request error. So I've triggered an error on Google servers by sending a bad request. And then there's arrow buttons here that let me go back. So I can go back to my last known good request and try something different. I still get a 200 okay. So the repeater tab is one of the most useful features of Burp Suite when you identify a particular request that you want to just like, mess with, tamper with, see what's happened, try to invoke an error, see what happens if you change something. If I were to change like foobar to pajamas, I can type that in and then hit send. And maybe I'm curious, like, okay, does the word pajamas occur anywhere in the response? There's a search bar down here, and I can search for the word pajamas. There's 439 matches. And so there's one. It's part of a URL string here. So idea is, as we're looking for maybe things like reflected cross-site scripting, where we want to know if we send something to the server, does it return back to us? We can use something like repeater, send a special phrase, search for it in the response, see where it comes back, or try different things, remove cookies, change cookies, modify things. Did an error happen? Did it still work? This is really where we spend a lot of our time when we're doing manual testing. All right, has anyone been able to, or has anyone not been able to kind of follow along? Like, are most of you all set up with the browser? Is it working? If you're looking at Google or looking at something else, do you see data? The important thing is, do you see data in your HTTP history tab? Sweet.
Yeah, everything's good on my end.
Awesome. All right, I'm seeing a lot of yeses. You are officially a hacker. Yep, you got a black hat you can put on, or a ski mask. That's the real hackers wear, ski masks while they hack. All right. So I won't full screen the slides again, but for the purposes of demonstration, I've actually created a simple web application that has a couple different vulnerabilities like the ones we talked about. And this will be the target of our joint exercise that we all do together. So disclaimer, I am a comic book nerd, so this is entirely DC Comics Justice League themed. The Justice League headquarters that orbits the Earth is called the Watchtower. And so this is an online portal that's intended only for Justice League members to access the Watchtower. And our scenario here is that we are penetration testers that have been hired by Lex Luthor's Luthor Corp to try to find vulnerabilities or break into the Watchtower portal that the Justice League uses. And the website is https://watchtower.ropnop.dev. And what we're going to do is we're going to want to open that up in our Burp Suite browser, and this will be the site that we're going to start looking at together. So watchtower.ropnop.dev. Looks like it immediately redirects us, or it gives us an error message here that we must be a member of the Justice League to view this site. And it gives us the option to register ourselves. Before I go further, I will show one tip that is a sanity saving tip within Burp Suite. As you saw, your browser is very noisy. It's sending a lot of stuff in the background. When there's a particular site that we want to focus on, we can filter out everything else from, oh, sure, I'll paste the URL. We can filter out everything else from Burp Suite. So I will show you how to do that. If you have browsed to the watchtower.ropnop.dev site and then go in Burp Suite to the target tab again, and you'll find the site map, we'll now see watchtower.ropnop.dev listed here on our sitemap. If we select it on the top level, the whole domain, and right click, Burp has a concept of scope, and we'll add this website to the scope of what we want to test. So we can right click and say add to scope. And then Burp will ask me, you've added an item to your scope. Do you want Proxy to stop sending out of scope items to the history or other Burp tools? And we will say yes. And what this will do is basically tell Burp to ignore everything that's not watchtower.ropnop.dev. And that's perfect for us because that's only the site that we're actually looking to test right now. Once that is in scope, if we go back to the HTTP history tab, there is a filter button. It's not super obvious that this actually is a button, but if you see where it says filter hiding CSS image, you can click this and it'll bring open the filter settings. This lets you control what gets displayed in the history. And like by default, it does filter out certain things like images or CSS. But the main thing that we want to check is show only in scope items. And if we check that and hit apply, everything gets a lot cleaner to look at because now I'm only going to be looking at the requests that go to the Watchtower site, which is what I'm trying to test right now anyway. So not a requirement, but just to help things be a bit clearer whenever I'm testing a particular site, I like to just add it to scope and ignore everything else so I can only see the stuff that I care about.
Since we still have to do that, what is adding it to scope and clicking yes do if you still need to filter it?
So I filtered because I already had things in there before I added it to scope. So adding it to scope and hitting yes stops future things from going in there. But then adding the filter, it didn't remove what I had already browsed before I'd added it to scope, if that makes sense. So yeah. I was just filtering out like the history of the history.
Thank you.
All right, well then let's get to hacking. Let's try to figure out how to get into the Watchtower. So it looks like everything we click just redirects me to this login page. And I must be a member of the Justice League to view this site, but there does appear to be a register page. So if we register, it asks us for our superhero name, our secret identity or our real name, and a registration code, which is the secret code that should have been given to us by Batman or Superman. So let's see. What I like to do is if we're following along here is just like try it like I normally would, like a user, and just see what happens. So I'll put Ropnop's my superhero name. And I don't know what my registration code is, so I'm gonna put something random like foobar in here and just see what happens. And I get a bad registration code. We can follow along in Burp Suite and we can see the actual request that we made to do the registration is a post request / register where it sent us the name, identity, or it sent the name, identity, and the code here, but it gave us an error message, or it redirected us back to the login page. So as we dive into a site like this, the first thing that I like to always do is try to understand what this form is doing, where it's going, and basically what it was written in. So I'm not even going to use Burp for this part. What I like to do is just right click and view page source. And we can do this within the browser, and we can see the actual HTML that came back from the server that our browser is rendering right now. And kind of scrolling through here, you can figure out a few things like, it's using jQuery, or it's using popper.js and bootstrap.js. Keep scrolling through, and here I can see the form that it was asking me to fill in. It's a /register. It's going to /register with a post. But one thing that immediately jumps out to me, and apologies because it's in green on black, so it's probably hard to read, but if you're following along on line 88, there's a comment. You may laugh and think this is contrived, but you would be very surprised how often in pen tests in my career, I have just found comments in source code that should have been removed before it went to production that are still there. So there is a comment in the source code right now that says, the default registration code Justice League always works, but I'll make sure to change this before going to prod. So we have a code here, Justice League in LeetSpeak, that we can test out. So we can copy that, paste it in the registration code, hit register, and first step bypassed. We've gotten into the Watchtower portal and registered ourselves as a new superhero. All right, people able to follow along with that one? Please stop me if I'm going too fast or we need to backtrack on anything. Main takeaway or lesson there is, yeah, always take a look, read source code. Sometimes the dumbest stuff is like, yeah, always what lets you get in default credentials, passwords, etc. Okay. All right. So now we'll click around, and I'm going to breeze through these just so I make sure we have plenty of time for the CTF. But it looks like there's several different functionalities here, and I'll just start left to right. We have something called Oracle Search Villains. And it says this form will let you tap into Oracle's API on all known villains, enter a search term to see if there are any matches. So I'll use it as I normally would and try searching for a villain like Joker. Hit search, and I see, yeah, some results came back with a link to Wikipedia about the Joker. Now, let me look at that in Burp Suite and figure out what happened here. I find in mine, it's request 159. There's a GET request to /oracle/villains with the search term of Joker and a response. So let's dive into this particular request. So I want to send this request to repeater. I'll right click and send to repeater. And I see my request here. It did send a session cookie, but let's just send it. And the main thing I'm looking for, like I gave a hint earlier, is there any possibility here of content injection? Like, is the thing I'm sending to the server coming back to me, like reflected back to me? So I know I searched for the term Joker. So if I go down here and I look for Joker, I can see that it did come back from the server in two spots. It came back in some HTML right here, and it also came back inside a URL right here. So to me, this tells me, okay, there's a possibility here of content injection. What happens if I can send it like special characters? Could I get JavaScript to come back inside the response? So I'll use repeater to test that. And what I can do is change the search token or search parameter. And what I'll try is just putting in a bunch of random characters, including special characters, to see if anything comes back unencoded. So let's try like ASDF, quote, close bracket, bracket, semicolon, dash, dash, single quote, just some special characters. Hit send. And then over here, I'm going to find where ASDF occurred. And it occurred two places. The first place here everything was HTML entity encoded. So this is good, meaning the server is doing its job. It took in special characters, but it made sure to sanitize them, it encoded them, and it sent it back. But the second place that my search term returned, it did not sanitize it, and it actually looks like my quote was considered closing out this href, and then there's some new brackets here, and then none of my other special characters were encoded. So this is a big red flag for me. Does anyone, can anyone think of the vulnerability or the technique that we covered earlier that could potentially be exploited here?
You can write a script block.
Yep, exactly. So we said, you know, a common script just to see if it's going to work is to try like alert 1. So what happens if I put valid HTML that calls a script block with valid JavaScript inside of here? Hit send. Let's find alert. So we got close, but it still looks like if we can read this HTML, sorry if it's small, it's actually inside this quote body here. So it's a tag href quote, and then it's like /wiki/script alert 1. Any ideas or anything we could try to make sure to see if this will act? Like right now, this is just a string. It's just quoted inside.
Can you start it with a quotation mark to end that href?
Nice. Yeah, let's try that. So let's do a single quote, and then we'll do script alert. Yeah, now we're getting somewhere. So now the quote ends it, but then script starts, but actually still doesn't look right because this script tag is inside this a tag here. So what else? What can we try to make sure this actually works?
Close out that a tag.
Nice. Yep. I saw someone posted that. So if we close it out. Yeah, that looks right now. So now we are closing out the a tag, then opening a script block, and then calling alert 1. So this, from looking at the code, looks like it's going to work. The next step is to actually try this and verify it. What we can do is just copy this payload here. Let's go back now to the main application, and let's paste that into our search bar here. Hit search. Mine is loading.
It worked. It just took a minute.
It's weird. I don't know why mine is. Did I lose internet? Can you all hear me?
Yeah,
we
you're
can hear
here.
you.
Oh,
Yeah,
there we go. I don't know why my server blipped or something. So when we searched for that villain, we got a pop-up here that says alert 1. So we have just, yep, if we see this, we've demonstrated we now control arbitrary JavaScript injection on the watchtower.ropnop.dev domain. Now to demonstrate like why this is bad, right, or what we could do with it, I've actually created another page that you can follow along on luthercorp.ropnop.dev. I'll paste this in here. And there's actually all the exploits for the Watchtower are on this site. And the first one, XSS1. In a real attack scenario, this would kind of be what would happen. Say someone from Luther Corp sends Batman a link and it says, click here. Well, embedded inside this link is a malicious JavaScript payload that's going to call that Oracle Search API, and it's going to smuggle Lex Luthor's bad JavaScript into the Watchtower origin, execute it, and then read sensitive data. So let's watch what happens when we click here. We get redirected, and now there's an alert box that says, haha, Ropnop, I now know your secret identity is Ronnie Flathers from Lex Luthor. So little contrived example, but that's just me. I wrote a little JavaScript, malicious JavaScript thing that extracts the secret identities from your session cookies and displays it to you. So that's what a cross-site scripting attack would look like when it's actually being exploited. Hey, click this link, you click on it, and all of a sudden it reads some sensitive data or does something bad on that website for you. Did anyone else try this? Did it work? Did it read your secret identity?
Yeah, you got money.
Cool. Nice, Terrence. Yeah, that's defense in depth. Yeah, and at least like Luthor is nice enough, but that's how it always is, right? Like the super villains tell you exactly what they're doing and what their plan is. All right, so I'll move on. That's probably the most classic and simple example of cross-site scripting. That's a reflected cross-site scripting attack. Let's go to the heroes search under Oracle. And this is another search bar that also lets you search, but it lets you search for heroes. And there's a table of heroes here, and it looks like if I start searching for like Superman, okay, as I type, it's filtering the table for me. So I can type super, and then it's filtered out to Supergirl, Superman. And if I type an M, now it's filtered out to Superman. So this tells me there's like a reactive type JavaScript client or JavaScript code on my client that's like dynamically changing this table for me. What I'd like to do here is first I would look in Burp Suite and figure out, did my Superman search term ever get sent to the server? And if we look at our HTTP proxy, all I see is a GET request to /API/heroes, and it returns like a JavaScript array of superheroes, but my search term was never actually sent to the server. Which means as I'm typing my letters, they're being interpreted and read by JavaScript, but not actually being sent to the server. Another thing that I'll point out, that as I'm typing, if you follow in the address bar up here, what I'm typing is also being updated in the address bar. So it's /heroes and then /# and then my search term Superman. So since my search term is being reflected to me, I'm thinking, okay, maybe this is another opportunity for content injection, but because what I'm typing and sending is never actually going to the server, there's a different technique here. Does anyone recall a different type of content injection that could potentially be exploited here?
Reflected cross-site scripting.
Close, yeah, so reflected was what we did first. Reflected is where we send something to the server and the server reflects it back to us. But when we are just injecting something into client-side JavaScript that's being rendered, it's called DOM-based cross-site scripting. And this is the more like complex version of cross-site scripting, but it's also becoming one of the more common ones because of the prevalence of things like React and Angular that do all this logic on the client side.
Is this the storing in persistence one?
No, that's the third one, the third technique, which I don't actually have on this site. I didn't implement that because I didn't want my payloads if persistence is a bit more dangerous, right? Like if I were to store a payload, then any of you that visited it would also be triggered by it. So I kept that stuff out of here. But that is the third, that's correct. That's the third type of cross-site scripting.
But could you exploit that here is kind of what I'm asking.
You could not, no. I mean, I know that because I wrote it, so there is no functionality that it doesn't save or persist anything on this site. But that is something I would definitely want to test on a site that I didn't write, just to see if I could or not. This whole site is actually a serverless function. So there's no state when you close it out or you clear your cookies. It's just a brand new, every time you reload the page, it's a totally brand new instance. Okay, so to test for DOM-based cross-site scripting, I know that what I type here is going into the DOM because the DOM is being updated as I type. So the other thing, or something I would want to try to do is, can I inject, special characters? So if I do ASDF, there's no results for ASDF, but there is a link to Wikipedia here. What I'm curious about is this particular element within the DOM. If we right click and hit inspect, this is where Chrome is useful. We can find inside the DOM here where my ASDF like search term is. And again, sorry if it's small, but if you can find it, it's being injected into a header, an H5 header, and then it's also being injected inside the link here. If I put special characters or quotes or things like that, we can see that the DOM is updating dynamically down here. And we are in much the same situation as we were for the last one. So we'd like to try to break out of this href within the anchor tag and inject some script content. So if we remember how we did that last time, we can close it out, add a script, and try to pop alert 1, but I did not get an alert box. But what happened here? Well, we can dive in here. And the code looks totally correct. Down here, it's small, sorry, but there is the A tag, and then the A tag ends. And then it gives me a script block with alert 1, but alert 1 did not fire. Like the JavaScript actually did not execute that. I don't, excuse me. I won't expect any of you to know this because I think I glossed over it or maybe even skipped the slide that had this on there. But there's an interesting edge case here as to why a script block did not execute. And that's because script blocks, when you have open script block, JavaScript closing script block, the browser only executes those one time on page load. So when the initial page is being loaded, all the script blocks execute. But then if a script block is added after page load, it will not execute. The browser doesn't go back in time or back and keep looking for script blocks. Script blocks only are a one-time thing that only happens on page load. So in this particular case, we can't actually use a script block to execute JavaScript. However, there's other tricks we have up our sleeves that we can execute JavaScript without having to use a script block. Bonus kudos points to anyone. Can you think of any other way we could execute JavaScript without calling a script block?
Isn't there like, I don't know, shooting in the dark, but like JS query kind of thing? Language?
Yeah,
I never
well, that's
used
actually,
it.
yeah, and that's a really good idea because we know when we looked at the source code earlier that there was jQuery in place. So that's a good call. We could definitely look at doing something in jQuery.
I was thinking you could send in the, maybe I'm getting it all mixed up, but what about is this where you could do an Axios request somewhere?
Yeah, if Axios is being loaded, right, if we can call JavaScript, then we could call Axios. But we have to actually execute JavaScript first. Once we have JavaScript execution, then we can call Axios. Or we could call jQuery or whatever else happens to be loaded. I think I see.
What about on load?
Yep, you just got there, and it looks like Michael got there also. So event handlers. Yep, the browser in HTML has triggers that can call JavaScript functions when things happen. So there's all these different event handlers like on click, on mouse over, on page load, on error, that you can feed a JavaScript function into, and the browser will execute that JavaScript function when the event triggers. So I'll show like one, my favorite way to do this is to actually write a JavaScript function on an event handler for an error, and then trigger an error intentionally so that it triggers the error. So one way we can do that is to actually do an image tag, and we can load an image tag from a bad source like this. And we can see that it tried to load an image. If you see the little broken image icon down here, like there was an error because this image source X doesn't make any sense. So if we put an event handler listener on error to call JavaScript, this error will call JavaScript for us. And that looks like this. If we do on error equals alert 1. As soon as I finished typing that out, I got an alert box pop up with 1. And that's because I intentionally triggered an error with a source equals X, and then caught the error and said, when it errors out, I want this to fire an alert box. And as soon as it errored, it fired an alert box for me. Excuse me. So you have to be really creative when you are looking for cross-site scriptings like this. And yeah, I'm glad that some of you got to event handlers. There's all these like different crazy ways that you can execute JavaScript within a browser by like triggering errors or triggering like mouse click events or something like that, then causing it to happen and then calling a different JavaScript function. Like it gets very complex. But yeah, this is a classic example of a DOM-based cross-site scripting by intentionally causing an error and then calling malicious JavaScript when the error happens. And we can see that our search is actually part of the URL query here, which also makes it very easy to say, copy this URL and send it to somebody. And when the page loads, this will trigger. So if we go back to our Luther Corp website, XSS2 is the same type of XSS attack, but using the Heroes API instead of the Villains API, because this is DOM based. So if we click on this, we get the same malicious JavaScript. It reads my secret identity, but you can actually see the payload's a bit more complicated. You can see it in the search bar here. I used a different technique. So I actually triggered the onload event so that when it tries to load an image, it calls the fetch API to then evaluate that JavaScript text and basically hijack control. All right, so that's cross-site scripting. Those two are good examples, and definitely encourage you both in the Villains and Heroes API. Try constructing your own payloads. Try doing things yourself. There's different ways you can exploit this, but these are two good examples of an insecure server that is vulnerable to cross-site scripting.
Is this stuff that people actually manually put in, or are like programs? Sorry, are programs generally used for trying to do the payloads?
It's well, both. So there are tools that will scan for this by basically trying a bunch of different techniques, and there's ways that you can inject a cross-site scripting payload and then detect if it executed or not. There's actually a whole class of vulnerabilities called blind cross-site scripting, which is really cool, where you can like say you inject a cross-site scripting payload into like my payment profile, and it doesn't trigger when I look at my payment profile, but maybe there's an admin on the back end that loads my payment profile into some internal application, and that application is vulnerable, and when they load my payment profile, it triggers on their laptop. There's tools that you can use to do blind XSS testing where there's a specific payload that when it triggers will call out like phone home, and you can send that out and blast it like everywhere on the site, and then sit back and wait. And if your server gets a phone home, you'll be like, oh, that just triggered. Someone clicked on that. I don't know where they came from, but that happened. And so that's a way you can detect whether like something was actually fired automatically with a scanner. But a lot of it is manual, just knowing what to look for, or maybe you find a particular area where like there's data that's being reflected, but only certain things are encoded and sometimes things are not, and you have to get real creative. Sometimes there's a web application firewall in place that blocks certain things, so you have to like bypass that. And there's all sorts of like evasion checklists. Like OWASP actually has a whole cheat sheet on XSS filter evasion. So if say something's like blocking particular words like script, there's ways that you can like put comment characters or like special characters in that basically like fool the defense system, but actually still execute. And there's all these different ways of obfuscating or sending bad JavaScript and bypassing events. Like look at this one, right? If my on-air handler, I could encode it entirely as like HTML entity and hex, but that still is valid JavaScript and it'll execute, or things like this. There's a whole cat and mouse game of finding this stuff. Yeah, Logan, so stealidentity.js, you can actually look at that because it's hosted on that Luther Corp website. It basically is reading the cookie value and decoding it. And it's just, like I said, a contrived example, but a real malicious cross-site scripting attack would do something worse, or it wouldn't like notify you that you've been compromised. It would just silently like steal things in the background. Oh yeah, thanks. Yeah, so for those curious, this is all that the steal identity JavaScript is. It's just 3 lines, 4 lines. All right, so moving on, I want to show the other 2 vulnerabilities, and then for practice, and then we'll move on to the CTF. Yeah, Dalton, let me try to breeze through these next 2 tabs, and then maybe in like 10-15 minutes, we'll take a break while I set up the CTF. Does that work? Cool. All right, so the location database. If we move on to the next tab, this form lets us tap into the Justice League's database of superheroes operating in cities around the universe. And so location name, we can type something like Metropolis. Do a search, and we see that Superman operates in the city of Metropolis. So bit of a hint here, the fact that it says Justice League's database and it's called locations database. Any particular type of vulnerability we might want to test here for?
Sql injection.
Yep, exactly. So if we can kind of think maybe on the back end what it's doing, it's taking in a location name here, constructing a SQL statement, and then reading from a database to figure out if there's any superheroes operating there. So one thing I might want to try doing is just putting in some special characters. Yep, and I triggered an error. And the error is actually super helpful. It tells me it's a SQLite error, syntax error, bad query, select star from locations where location like quote ASDF, and then all my special characters. So this is telling me right off the bat that it's building a query called select star from locations where location like, and then inside my quotes is a the variable that I put in for the location name. So one thing that I'll try is what happens if I just do like ASDF, I get no results. But if I do ASDF single quote or 1 = 1, which we talked about, should return everything that's true and hit search, I do get everything from the database. So I do get everything returned back, and it looks like it dumped the entire table of hero names and locations. Now, I'm going to mostly do this for demonstration purposes, and I'll move quick, but I encourage you to follow along on your own time, or you can come back to this site and try things. But since I know that this is SQLite already, because the error message told me it is, I know that there's particular things I can do that will enumerate information from the database. So one thing I can do is do something like ASDF union select 1 SQLite version. So that string that I just put there, sorry, I hit submit too soon, but this string actually does something. It calls a function called SQLite version, and it returns here in the column the particular version number that the SQLite database is, 3.31.1. So now I know I'm talking to the database and I'm just executing arbitrary SQL. The next thing that I could do is something like union select name from SQLite master, where type equals table. This is a particular SQL query to tell me all the table names within the database. And I see that there's 2 tables. There's a table called identities and a table called locations. Well, we already looked at the locations table. What's this identities table? That sounds really valuable. So let me try ASDF union select star from identities. So now I am closing out my query, union another query, and asking it to select everything from a totally different table within the database. And now I've enumerated data that came back to me on the web application, which is the hero's name and their secret identity. And now I'm dumping data from the database that I shouldn't have access to by sending specific SQL queries. So I know I went really fast there, just because I have muscle memory and I've done this before. I know like the particular SQLite query commands, but the basic idea is that anything I put after this quote can be valid SQL, and that it will be executed, and it'll let me select things from other tables or dump data or other things like that. Cool. All right, the last one that I will cover is the credits tab. So there, as you log in, it looks like you have 1,000 credits available, and you can transfer them to other heroes. So we can select Aquaman and give him 5 credits. And if we hit transfer, we successfully transfer 5 credits to Aquaman, and we have 995 credits remaining. And yeah, looks like someone has 1 million credits already. So awesome, you found another vulnerability. This thing's littered with them. So there's even more than I'm talking about. And this site is up all the time. So after the class, you could just bookmark this and keep playing around with it. But let's figure out, okay, what happened when we actually transferred 5 credits to Aquaman? I'm gonna go back to Burp Suite here, and I'm gonna find the actual request. It was a post request to /credits. And down here, recipient was Aquaman and the amount of 5 credits. And it sent my cookie and it gave me a 200 OK, and that worked. 2 things jump out at me immediately when I see a request like this. One is this is a action or a state changing request. I'm actually transferring money when this request goes through, or transferring credits. 2, it's using cookies. My session cookie got sent. And then 3, I guess 3 things. I don't see anything about CSRF here. I don't see a CSRF token or a CSRF header. So this, to me, is ripe for abuse of cross-site request forgery. So I'm going to jump ahead to the actual payload because I've already constructed it. But if we go to luthercorp.ropnop.dev and click on the CSurf page, I will first show the source code here. It's asking me to say, click me, but let's look at the source code. And it's really simple. There's a form that posts to credits, which is exactly the request that the server expects, with a hidden value and a submit. Now, what happens when I click this is my browser will send a post request to Watchtower/credits. It will look in my cookie jar. It will say, oh, you have a session cookie. I will send that with this request. And it'll send the post request with that cookie. And let's see what happens. So if we click this, all of a sudden I'm automatically redirected here and it says successfully transferred 100 credits to Lex Luthor. So this is what CSurf looks like in practice. You either click something or a link is sent to you, then all of a sudden you're redirected to like a success page and an action was taken that you did not want to actually happen. And so we just sent 100 credits to Lex Luthor. We dropped down to 895 credits. And all of that happened because if we look at Burp Suite, we sent a post to /credits to Lex Luthor for 100, and it automatically included my session cookies. And since it didn't have any other CSurf protection, the server accepted it. It was a valid request, and it deducted and sent my credits over to Lex Luthor. All right. So that covers cross-site scripting in the villains and heroes, Sql injection in location DB, and CSurf in credits. There's other vulnerabilities on this page that I would encourage or welcome you to experiment or poke around on your own. There's a Batcave admin panel that if you can get for example, get access to. There's also secret keys that could potentially be abused or stolen. But I will leave that all for you to experiment and learn on your own time. Any questions before we break on walking through this? Hopefully you all were kind of able to follow along or exploit yourselves with some of those LuthorCorp exploits. Any questions, or is anyone having trouble with Burp Suite following along? Cool. All right, so let's take let's see, it's 2:15. Let's take a 10-minute break. We'll come back just a little before 2:30. We'll kick the CTF off at 2:30 and let it run until 4 or a little before 4 so we can wrap up. So yeah, everyone take a break. I'm going to close out my Burp Suite and open a fresh session for the CTF so I don't need to save any of that. And I will stop sharing. And I will open up the CTF for registration and be back in 10 minutes. See ya. Okay, let's try that again now that I'm unmuted. So hey everyone, from now until the end of class, we're going to be kicking off our Capture the Flag or our CTF tournament. This is a CTF platform that is written and maintained by OWASP. It's called Security Shepherd, and it is a guided challenge-based CTF for web applications. I've spun up a Security Shepherd server and opened the registration. It is at owasp.codeplatoon.ropnop.com. I will paste this in the chat. And so what I'll do is I'll kind of walk everyone through getting registered and set up. You can self-register an account, create your own username and your password. Just choose a random password, but just don't forget it. You don't have to put an email address in. I never set up the email functionality. The idea is to use the Burp Suite proxy for this CTF because some of the challenges will be a lot easier if you have the repeater tab or some of the other tabs within Burp Suite. And they are sequential challenges that will get progressively harder. And there are points that you will get for completing each challenge. I'll be displaying a scoreboard, and we will let this run until about 3:55. It's about an hour and a half. And then I will call it, and whoever is top of the leaderboard or top of the scoreboard at 3:55 will be getting a book sent to them courtesy of OWASP on web application security. So let's all walk through and open up Burp. I closed Burp and opened up a new one, so I don't have any of my previous settings anymore. And I'm just going to open a new browser. And I'm going to go to owasp.codeplatoon.ropnop.com and register my own account. There we go.